Hello everyone, welcome to Ansarkari. In this video, we'll be continuing with the concept number 21 of permutations and combinations. It says the number of ways in which two m different things can be divided into two equal groups, each containing m things is this. So if you compare this formula with the previous formula, that was m plus n factorial and then m factorial into n factorial. This particular part in this formula is similar to this thing if we, because equal, right, the difference is just about two equal groups we are dividing into, and in the previous cases it was into two unequal groups. That is the reason for this, and this 2 factorial is just the extra thing which needs to be written because of the equal distribution that we are including. And right now we are dividing into two equal groups. Suppose you are dividing into three or more equal groups, then everywhere 2 should be replaced by 3. That is 3m factorial, then like m factorial raised to the power 3, then into 3 factorial. So the number needs to be replaced everywhere depending upon the number of groups, equal groups that we are dividing into. So taking the 17th question, in how many ways can 24 different things be divided into 4 equal heaps so that each heap may contain 6 things? Now we need 4 equal heaps and the things that they contain is 6 things. Like one heap should have 6 things. So here it will be like 4m factorial. Then we'll have m factorial raised to the power 4 as we have in this formula, right, into 4 factorial because of the equal distribution of equal things. Then we'll have 4m. Now m here will be equal to 6, so it will be 24 factorial, then 6 factorial raised to the power 4, and then 4 factorial. So this particular thing will give us the answer to this question. Now the concept number 22, the ways of distributing 2m different things among two persons into equal groups each containing m things. Now the situation is exactly the same, just that the difference is here we were just normally dividing into two equal groups. Again now we have included two persons. Now persons are distinct, right? They have to be different. So there will be two factorial ways of arrangement. तो पहले वाले केस में it was 2 factorial, right? But now since we have two persons again, so we'll cancel them out. So चीजें cancel हो जाएंगी. That is why we'll be left with just this particular formula. Now this is the question for that. In how many ways can a pack of 52 cards be divided equally? Now again we have equal distribution. So like in one there will be 13. Like one player will have 13 cards, right? Among 4 players. Now here we have 4. So in place of 2 we'll write here 4. So it will be 4m factorial divided by next is m factorial raised to the power 4, and 4 factorial we do not have to write here because it gets cancelled because distinct players are here, distinct players are included. तो जिनमें हम distribute कर रहे हैं we have to focus whether they are distinct or not, and जिनको कर रहे हैं वो भी, we will see further, we will see different cases in which even the things that we are distributing are identical, that is they are similar and not different. So m here will be equal to 13. So it will be 52 factorial, then again 13 factorial raised to the power 4. So this will give us the answer to this question. The number of ways of distribution of n identical objects to r persons or groups, each of whom can get 0, 1, 2 or more objects is this. So this is the particular formula for this case. And now the difference in this case and the previous cases was, the major difference is that here the objects are identical. In the previous cases that we read, all the objects were distinct, that is different. And here we are dividing into r persons or groups, each of whom can get 0, 1, 2 or more objects. So what it means is that out of these n objects, if you are dividing into 3, 4 or any number of persons or groups, it can happen that one group will get like all the objects and all the other 4 or 5 groups, anything that is left will get 0. So this case of 0 is also included in this case. That is, none of the persons or groups get anything, right? This case is also involved. So let us take this question now. What is the number of ways of distributing 8 rupees 10 coins among 3 beggars? So now the number of coins that we have is 8, and all the rupee 10 coins will be identical. We'll take them to be identical, of course. The number of coins that we have is 8. So n will be equal to 8, and the people that we are distributing into 3. So obviously each person will be distinct also. So here r will be equal to 3, and according to the formula it will be 8 plus 3, that is n plus r minus 1, and we'll write here c, and it will be r minus 1, that is 3 minus 1. This is the formula. We do not have to get into details of this formula, it will be very complex. So we'll just easily remember this formula for the case where the objects are identical and are being divided. And in this formula, the cases that even this zero thing is involved, you need to remember this, that it can happen that none of the persons or group get anything, right? So 8 plus 3 here will be 11, minus 1 will be 10. So it will be C and then 2. So we'll just quickly solve it once. 8 factorial. Now 5. So the answer for this thing will be 45. So there will be total 45 number of ways of distributing rupees 10, 8 rupees 10 coins among the 3 beggars. Now the 24th concept is also similar to the 23rd concept. The difference is just this, that in this case at least one object is to be given to every person or group that is involved in the distribution. तो ऐसे नहीं हो सकता कि हम किसी भी एक ग्रुप को खाली हाथ जाने दें, right? Everyone has to have at least one object that are from those that we have, right, that are present. This will be the formula for this particular thing. Directly n minus 1, c r minus 1. So this is the example question for this particular concept. What is the number of ways of distributing 5 identical, again the cases of identical objects that are being distributed into 3 boxes so that no box remains empty. Now here the case is that no box remains empty. So here what happens is at least one object has to be present in each of the boxes. Therefore we'll directly write 5. Now n here is equal to 5, right? The things that we are distributing, and 5 identical balls we have. Then r is the things that we are distributing into. Here we'll accept the 3 boxes to be distinct and not same. So r will be equal to 3 in this case. So it will be 5 minus 1c, then r minus 1, that is 2. So it will be 4c2. And after solving we'll get 4 factorial is 24, and then 2 factorial into 2 factorial we'll get equals to 4. So it will be equal to 6. So 6 will be the answer to this question. Thank you.